First, we're going to explain how to set up the apparatus for simple distillation. To start, let's gather all the materials. We need a Bunsen burner, a ceramic pad, a round bottom, a condenser, thermometer holders, thermometer, receiving flask, a slop bucket, and 2 lab jacks. Take the ceramic pad and place it on the ring with about the ring 10 centimeters from the Bunsen burner. Next, clamp the round bottom. Fill the round bottom with the entire sample and 2 black boiling chips. Take the thermometer holder and grease it here. Next, place the condenser on the end of the holder and hold the condenser in place with 2 elastics. When sliding the holder on the thermometer, hold very close to the adapter and insert it, only a tiny bit at a time, or you may break the thermometer. Next, place the thermometer so that the bulb sits below the opening of the condenser. Now attach the 2 tubes so that the water goes in here, travels through the condenser, and goes out here. We do this so that the vapor from the solvent can get cooled down to become a liquid, and we can collect it in our receiving flask. Finally, position the 2 lab jacks so that the receiving flask is just below the tip of the condenser. Now we can start the simple distillation to determine the boiling point of the solvent. The boiling point is the temperature at which vapor pressure of the liquid equals the atmospheric pressure.
You're able to do this type of distillation because the boiling points are more than 30 degrees apart, aka not azeotropes. Before you begin heating the dichloromethane and acetyl mixture, you must have water running through the condenser. This is to cool the vapors so that they can be collected. Then you make sure the flame on the Bunsen burner is appropriate. It should be blue and should not make any noise. Then you heat the mixture very slowly and carefully to slowly raise the temperature. The first couple drops should be put into a waste beaker, known as the slop bucket. This is because it is possible that there are low boiling impurities that you don't want mixed in. When the temperature levels out, around 39.8 degrees Celsius for dichloromethane, you can begin to collect the solvent in the Erlenmeyer flask. Collect about 10 milliliters and record the temperature. When the temperature suddenly begins to increase or decrease suddenly, switch the beaker to the slop bucket. And then, to make sure that the solute, which is acetyl acetate, has no remaining solvent in it, you keep heating it until it reaches 105 degrees. You do this because dichloromethane boils way below that.
One way to test the purity of our compounds is to use the micro method. First, we get a small vial and place it into the capillary tube with the open end facing down. Next, the vial will be attached to the thermometer with a pair of elastic bands placed near the top third of the vial. The thermometer will be attached to the ring stand using a slotted rubber stopper and a clamp. The vial is then filled with a liquid compound, in this case either dichloromethane or ethyl acetate, using a Pasteur pipette. Do this until you have a depth of about 1 centimeter of liquid. Next, lower the thermometer and vial into a thiol tube filled with oil that is attached to the stand. The vial should be submerged about halfway, and the rubber band should have enough room to stay dry when the oil is heated and expands. Heat the side arm of the thiol tube using a Bunsen burner until bubbles come out of the capillary. Let it cool until bubbles no longer come out, and then heat it again. Make sure not to wait too long between the time the bubbles stop coming out and when you start heating again, as if oil goes into the capillary tube, you will need to start again. This process is repeated until the thermometer reaches the same number within 1 degree Celsius of the last trial, and the bubbles stop coming out of the capillary tube. The last thermometer reading will be the boiling point of your liquid. Another way to measure the purity of a compound is to use the refractive index. This is the measurement of how much light is bent when it passes through a sample of a compound. To measure this, we add a few small drops to the prism. Next, you close the lid, press read, and record the compound to 4 decimal points. You wipe out your compound, spray the acetone on a Kim wipe, and clean it out. Afterwards, you will compare the number that you received to the literature values of your compounds in order to find out how pure it is.
Next, just like the test of refractive index, we will use infrared spectroscopy and gas chromatography to determine and estimate the purity of the solute and solvent used. First, we'll use the IR test to determine the relative purity of our solute and its molecular structure. By using specific wavelengths and frequencies to bend and stretch the molecule's bonds, the specific bonding and stretching motions can identify the compound structure and the purity when comparing it to the found literature structures. Next, gas chromatography is a separation technique using the thermoscientific trace GC Ultra. But for this lab, we will simply create samples for our lab technician, David King, to analyze our samples by column separation for us to use to determine the purity and structure of our solvent and solute.
Adios, chemistry gang!